Welcome to the course on applied research from hypothesis to structural equation modeling. In this session, we are going to learn about understanding the meaning and purpose of structural equation modeling, differentiate between concepts, constructs, and latent variables, explain the role of multiple measurement variables, distinguish between exogenous and endogenous construct, and differentiation between measurement model and structural model. In this session, we are going to learn about the structural equation modeling, which is commonly called SEM. SEM is an advanced statistical technique used to understand relationships between variables. It is widely used in social sciences, management studies, psychology, and business research. For example, if we want to study how customer satisfaction is influenced by service quality and price, SEM helps us analyze all this relationship together in a single model. Let me now explain how data analysis methods have evolved over time, moving from simple techniques to more advanced and powerful approaches. In the early days, researchers mainly used simple statistical techniques based on what they could directly observe and measure. These methods focused on testing existing theories and not on building new ones. The models were simple and usually looked at one relationship at a time. Some common techniques used during this period were regression, ANOVA, and exploratory factor analysis. These methods worked only with observable variables such as age, income, marks, or sales figures. Hidden concepts like satisfaction, attitude, or motivation were often ignored or oversimplified. Now, let us move to the second generation methods, which developed from the 1990s to the present. Modern research problems became more complex. Researchers wanted to study unobservable or latent concepts such as customer satisfaction, trust, loyalty, or perception. To handle this complexity, advanced techniques like PLSM and CBSEM were introduced. These methods allow researchers to build complex models, work with latent variables, consider measurement errors, focus on theory development and prediction. Instead of studying one relationship at a time, second generation methods analyze many relationships together in a single integrated model. Now, let's explain what structural equation modeling or SEM really means and how it is different from simpler types of analysis. Univariate or bivariate analysis, where we study simple data relationships. Usually, we examine how one variable affects another variable, shown here as A leading to B. In multivariate analysis using SEM, you can see that one variable is connected to many other variables at the same time. Structural equation modeling or SEM is a procedure used to study dependent relationships between variables. This means SEM helps us understand how one variable affects another variable. Unlike simple statistical methods that look at one relationship at a time, SEM allows us to analyze many relationships simultaneously. Here, we have divided the definition of SEM into four parts: dependent relationships, set of concepts and constructs, latent variables, multiple measured variables, and integrated model. Let's explain one by one. First, we will see what is dependent relationships. Dependent relationships here mean a series of dependence relationships that automatically means that you will use them if you have more than one dependent variable in your equation. So that means only one equation with one dependent variable is not there. Rather, there are different variables leading one to the other. So, in this case, it is a series of dependence relationships. Here, organizational readiness (OR), risk and governance (RE), and skills SK are the independent variables that initiate AI adaptation. AI, the AI tool integration and implementation. AG, agile AI synergy and process alignment. DQ, the data quality and model reliability. TP, technical performance and scalability. PE, process efficiency and quality assurance. HF, the human factor and team dynamics, and OA, overall assessment, are all dependent variables. Now let us first understand that what is concept, what is construct, and why do we call it a latent variable. Concept is a theoretical thing. So, whatever way people describe something in their mind is called a concept. Example, concept of stress, concept of satisfaction, concept of loyalty, concept of financial literacy, concept of financial risk tolerance. So, all these types of things are concepts. In old papers, you don't see a empirical study, rather, you see literatures or theory explaining the concepts. So, actually, everything starts from a thought, and how a person defines that thought becomes a concept in literature. These concepts are hidden in a person's mind, basically, and you have to somehow bring it out. So, something which is hidden is latent. So, that is why we call it latent variable. Whatever concept you are trying to measure, that becomes a latent variable. Objective way here means that there is no standardized unit of measurement for this. So, if such type of variables exist in your research, whatever topic you are researching, if you have variables which are latent in nature, the concept which cannot be measured objectively, then you have to find out a way to measure them. So, what do? You construct this variable or the meaning of this concept. You actually translate the latent variable into a construct. So, you construct that variable, or you construct a measurement for that variable or for that concept. So, that is called construct. That is why we say construct, because there is no measurement available. So, if they are latent, you have to construct the meaning of this concept to be measured in a numerical way. So, that is why SEM is required for such newly constructed concepts. Here, measurement means assigning numbers to variables using clear and consistent rules. Some variables are concrete, like height or weight, and can be measured directly. Other variables, called latent variables such as satisfaction, trust, cannot be measured directly. In this example, restaurant satisfaction is a latent variable. It is measured using indicators like taste of food, service speed, staff knowledge, atmosphere, and value for money. What do you mean by measured variable? Something is latent. That means I cannot measure it directly. So, I have to measure it through some variable which I can measure, which is measurable variable. So, what is a variable? This is the question in the questionnaire, or what you say the items. So, whatever items you are giving to the respondents in your questionnaire, where you ask them to either agree or disagree, or you may ask them that how many times, something like that, or some how frequently you do, or it neverly, rarely, and so on, or very frequently. So, there are different ways of asking the same thing, and from these statements, you will construct the latent variable. So, through multiple measured variables, we intend to measure a construct. The numerical value calculated for the item is called indicator, but ideally, one item for calculating a latent variable should be avoided. At least 3 items or 3 questions should be there to calculate a latent variable. All hypotheses must be examined within a single integrated analytical framework. Accordingly, only one comprehensive model should be specified and estimated, and the analysis should be executed once. The resulting estimates are then interpreted as effects, which is observed in the simultaneous presence of all specified constructs, such as independent variable, dependent variable, mediators, moderators, and any controllable variables, which ensures that each relationship is assessed while accounting for the full set of interactions and dependencies which is embedded in the model. I hope now you are clear what it is an latent variable, indicator, and relationship between constructs. In a multiple regression equation, you have independent and dependent variables. Similarly, in SEM, we usually call them exogenous and endogenous constructs. So basically, exogenous construct is an independent variable, which means no other construct in the model is actually explaining this concept. This is completely independent. That's why it is called exogenous construct. Exo means outside the model, which means no construct inside the model is leading to this construct. This is completely independent. Endogenous, on the other hand, are the dependent variable in your model. SEM cannot have more than one dependent variable. That is why it is important to understand endogenous construct, which means a dependent variable. Here, the inner model shown with arrows between circles represent theory. It explains how these constructs influence one another. The outer model shown with arrows connecting circles to rectangles represents measurement. It explains how abstract constructs are converted into data using indicators. A strong SEM result requires both parts to be well worked out. A good theory with poor measurement fails. Likewise, excellent measurement without a sound theoretical structure also is meaningless. Once you have developed that model and you know what are the variables that are there in your model, now you should know, will you be doing formative or reflective? Accordingly, you will collect the data. You can have reflective constructs, or you can have formative, or you can have both. You can have both in the same model too. In reflective models, causality flows from the construct to the indicator. The assumption is that the latent variables exist first and it influences how people respond to survey questions. For example, if a student has high academic stress, they are likely to report sleep problems, anxiety, and difficulty in concentrating. So these indicators move together because they reflect the same underlying condition. In formative models, the logic is reversed. Indicators come together to form the construct. Here, the construct does not exist independently of its indicators. Consider digital literacy. It may be formed by skills in word processing, data analysis, online communication, and cybersecurity awareness. These indicators do not need to be correlated. When building SEM models, remember this sequence. First, clarify your theory. Second, decide how each construct should be measured. Finally, test everything together in one integrated model. So, SEM rewards conceptual clarity, and weak theory or confused measurement will always surface in the results. In the next session, we will move towards explaining PLSM versus CBSEM and the pillars of data execution. Thank you and see you in the next session.